Hello guys, hope everything is going well during the quarantine. We're going to make a brief explanation on the circulatory system based on what you have read, but most of all based on what you have answered in the homework. Okay, so we're going to make a little explanation, basic explanation on the circulatory system. Obviously, so far obviously to you, the circulatory system is in charge of circulating blood all around the body. We will talk about blood later on, but then the circulatory system is in charge of making blood circulate all around the body. Okay? Uh, Blood contains oxygen, glucose, waste materials, etc., etc. So it needs to circulate all around the body, basically transporting substances. Now, how does it move? Well, we have a pump that works on the blood that pushes the blood uh, all around the body. That pump obviously at this point again is the heart. Okay, um, how does it work? Well, actually, we said that the heart pushes blood. It's very difficult to push a fluid. It's very difficult to push a fluid such as blood. It's very difficult to push water when you're in the swimming pool, for example. It's very difficult to push air in a room. Okay, you might make it circulate with a fan, for example, or with a pump. So what is the work of the heart? The work of the heart is just to squeeze. The heart surrounds the blood. Yes, the blood flows inside the heart. And when the heart contracts, it pushes inside. Okay, it pushes towards the inside. Yes, pushes towards the inside, pushing the blood in out of the heart. Now, the heart, and this is a little detail, moves moves through the heart in only one direction because the heart has got these valves that you can see here. Remember, what are these valves? It's quite simple. It's one-way doors. That is, blood can push inside, yes, opening the valve, right? And when the blood goes backwards, the backflow, famous backflow that you mentioned in the homework, when the blood flows backwards, the blood itself closes the valves. Okay, the blood itself closes the doors. Okay, so blood cannot return. Right. The same happens when the blood goes from the atrium, first chamber of a heart, to the ventricle, second chamber of a heart. By the way, this, as you can see here at the bottom, is the circulatory system of a fish. Then we will see how this is true for our circulatory system, for mammals and birds' circulatory system. But then here we have the atrium. The atrium pushes blood into the ventricles. The atrium only pushes blood into the ventricles. It, as some of you said, it receives the blood, it's true, from the veins, true, but then it pushes the blood into the ventricles. What for? So that the ventricles, that we will explain later on, have more pressure there to push blood. But we will explain that later on. So that atrium, ventricle, when the ventricle contracts, it also closes these valves that are here in the middle. Yes, the atrioventricular valve. And when the ventricles contract, the blood pushes onwards into an artery. Doesn't matter now what the name of this artery is, but basically, as you can see, the blood that is flowing through the fish heart is deoxygenated. It doesn't have oxygen, so it has to go to the gills. Remember those structures next to the neck of the fish, on the side of the head of the fish, which are in charge of breathing under the water. It's true, we call it breathing, okay, but we will see that later on when we see the breathing system. We will compare it with the breathing system of a fish. Basically, when the blood arrives to the gills of the fish, it has to branch out into many, 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 many tiny, tiny, tiny capillaries, as you can see here. Yes, which will allow that exchange to happen. Yeah. What is the problem? The problem is that when the blood gets to the gills and to the capillaries in the gills, the pressure that the blood had is quite lost. So when the blood gets out of the gills in the fish, the blood has plenty of oxygen but quite a low pressure. At this point, when the blood gets out of the gills and now will circulate through all the body of the fish, yes, through the muscles of the fish, through the liver of the fish, through the digestive system, reproductive system, the nervous system, etc., 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 it will have plenty of oxygen but a very low pressure. It doesn't matter here. It doesn't matter much because fish are quite particular animals that do not need much blood. Sorry, they don't need much oxygen and glucose. Okay, they don't have to maintain a body temperature, for example, as we do. So they can cope with little oxygen, right? A little bit more maybe than what invertebrates, between inverted commas, invertebrates might need, but they need more than them, but less than us. Okay, so by the time the blood that was at a lower pressure already reaches the body, the muscles, the liver, and the digestive system, the nervous system, etc., all the parts of the body of the fish, it branches out into capillaries, so the pressure goes down to zero. So when it goes back to the heart, it has to be pressed again, right? Now, we cannot cope with that. We cannot cope with that. So let us see what happens in our circulatory system. This is our circulatory system. So here we are in the blue part. When the blood gets out of the heart and into our lungs, yes, it goes to the lungs. You can see that the lungs are nearby here, are very close to the heart. So when the blood gets to the lungs, it opens up into many, many, many capillaries. Remember that the lungs occupy the whole of our thorax. Okay, so it's a big volume, all right? So our thorax is quite full of blood. You can see that in the picture when they shoot or they stab somebody in the thorax. It's quite a bloody scene, isn't it? Well, that blood that comes into the lungs will lose a lot of pressure and gain a lot of oxygen, as you can see here. Yes, that oxygen will have to be pressed again. That blood, sorry, with oxygen will have to gain pressure again because it won't be able to reach our body. Not only because our body is big, I mean, sharks can be pretty big and sharks are fish, but also because we need much more oxygen. We need to maintain the body temperature, and that requires a lot of oxygen, a lot of energy. So, when the blood that has left the heart and got into the lungs returns to the lungs, it returns to another heart. What? Well, yes, this side of the heart, yes, which is the left heart. What? The left heart, but it's on the right here. Well, the left heart is a name given to this part of the heart, yes, that contains oxygenated blood. The blood that comes from the lungs contains plenty of oxygen, and so it can be pressed again, but this time pushed to the whole body, and so it will go to your muscles, the muscles in the arms, the muscles in the legs, the muscles in your abdomen, okay, your abdominals that you are must be practicing these days for sure, to your nervous system, okay, that is quite resting in these days, to your digestive system that must be working pretty well these days, etc., etc., etc. So, after passing through the all these organs in the body, it loses all the oxygen. So there we go with the blue blood again. That obviously the blue is a representation. Blood is always red, a little bit brighter, a little bit less bright, if you wish. But then that blue blood has to return to the first heart, the right heart. I insist on this idea, gentlemen. We have two hearts. Unlike fish that only have one heart, we have, gentlemen, two hearts, a right heart and a left heart, each one with its atrium and ventricle, atrium and ventricle, each one with a valve between the atrium and the ventricle that doesn't let the blood go backwards, okay? And another valve that we cannot see here, but it's in the entrance of the arteries, okay? So we have two hearts, one of them containing blood without oxygen, carbon dioxide pretty much, what we call deoxygenated blood, and another heart with oxygen in it, okay? Now, little issue that I have seen in your answers in the homework. When can it happen that the deoxygenated blood, the blue blood, mixes with the red blood? Nowhere. Because actually, not even in the capillaries, it doesn't mix up. Actually, it is where the blood loses the oxygen or gains the oxygen. Gains the oxygen in the lungs, loses the oxygen in the rest of the tissues in your body. Not in the heart. I mean, what should happen? This wall that divides the heart in two, I remember a question in a multiple choice about this, is called the septum. You got it in the book. This septum is very important. It's a strong wall that separates the oxygenated blood from the carboxygenated blood or deoxygenated blood. That blood never mixes, okay? Well, actually, it did mix before you were born, because actually, before you were born, when you were fetuses, you didn't need your lungs. Actually, you didn't use your lungs, okay? Then we will see, when we see reproduction, we will see that you receive your oxygen right through here, through your belly, okay? So you didn't use your lungs at all. Actually, you don't breathe in your mother's womb, So there is very little blood circulating through your lungs before you're born, just enough for your lungs to go on growing, okay? But very, very little blood. So there is a hole in the middle between the two hearts, okay? And so the blood circulates from the vena cava, that is this vein that comes from the body, directly to the aorta, that is this vessel here, okay? This artery that gets out of the heart, okay? So that's pretty much what our circulatory system works like. I want to add a little idea. Here we have the representation in which we see how small the pulmonary circulation is compared to the large circulation, okay? The heart, here it is not shown how the blood gets into or out of the heart. That doesn't matter. We will see later on. You can pretty much see it in this case. But the idea is that the large circulation, yes, the large circulation, the systemic means body, okay? The body circulation is much larger than the pulmonary circulation. It is called pulmonary because of the lungs. We know that because we speak Spanish, but in English it doesn't make much sense, but we understand it. On the other hand, we don't say pulmons just in case, okay? I don't want to listen or read anything of the sort. Well, very good. I hope you understand this idea. Just the last repetition is that we have, unlike fish, okay, that have a single circulation, we have a double circulation, okay? That is, we have two hearts pumping blood. Thank you, guys. See you soon.